Hello students, today we will start, good afternoon everyone. We'll start today the lesson matrices. Matrices. First we will take synopsis. Okay, I will put the synopsis on the board. Here I'm pasting. Okay, here it is. If you arrange the complex numbers in the form of a rectangle, then that arrangement is called matrix. The matrix has rows and columns. The numbers in the matrix are called elements. If the matrix A has m rows and n columns, the order of the matrix or type of matrix or size of matrix is m by n. You have to read it as m by n. So if you have m by n matrix A, that matrix A is written like this. This element is in first row, first column. So 1, 1. First row, second column. First row, third column. First row, fourth column. First row, nth column. Because how many columns are there? N columns are there. Then this is in second row, first column, second row, second column, second row, third column, second row, fourth column, second row, nth column. Like that, third row, first column, third row, second column, third row, third column. Sorry, third row, first column, fourth row, first column, fifth row, first column, sixth row, first column, nth row, first column. How many rows are there? M rows. And like this, mth row, first column, mth row, second column, mth row, third column, mth row, fourth column, mth row, nth column. The elements are written like this. In short, you can write matrix A having Aij. The elements, instead of writing so many elements, you can write Aij and the order is m by n. The I, the row, changes from first row, second row, third row, fourth row, up to mth row. J, the column, changes from first column, second column, third column, up to nth column. In short, you can write the matrix like this, or in big, you can write the matrix like this. Two ways of writing. If in matrix, number of rows and number of columns, number of rows equal to number of columns, then that will be square matrix. The order will be n by n because n rows n columns. That is why n by n. Now, in a square matrix, A is a square matrix. The diagonal in A from the first element of the first row to the last element of the last row. First element of the first row to the last element of the last row. This diagonal, it is called principal diagonal of A. If A is a square matrix, you take the principal diagonal of A elements and find the sum. Add up all. What you get is trace of A, denoted by like this. Now, in rectangular matrix, number of rows not equal to number of columns. Zero matrix, every element of A should be 0. If m by n is the order of zero matrix, you write like this. Or zero matrix, you can write like this. Good afternoon, Soundarya. Row matrix, matrix has only one row. Column matrix, the matrix has only one column. Okay, next. There is something called a square matrix A, which is upper triangular matrix. What is upper triangular matrix? All aij's will be 0 whenever I is greater than j. Whenever row number is greater than column number. Who is writing on the board? Don't write anything on the board. Row number is greater than column number. The elements will be 0. For example, this is A11, A12, A13. Second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third. This is 3 rows, 3 columns. Whenever the row is greater than column, row is greater than column, this is 0. Row is greater than column, row is greater than column. All these are zeros. So this is called upper triangular matrix. Similarly, lower triangular matrix. The elements will be 0 whenever row is less than column. For example, you have A11, A12, A13, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. Whenever row is less than column, row less than column, row less than column became zeros. All of them became zeros. So this is lower triangular matrix. Such a matrix. Triangular matrix means, on the whole, either an upper triangular matrix is called triangular matrix. Lower triangular matrix is also called triangular matrix. Good afternoon, Kumar. So both these matrices are called triangular matrices. Next, diagonal matrix means both upper triangular matrix, lower triangular matrix, every element in the square matrix is 0, except the principal diagonal of the matrix. What do you mean? Again, I repeat. A square matrix is a diagonal matrix if A is both upper triangular matrix and lower triangular matrix. What do you mean? Upper triangular matrix, lower triangular matrix. Suppose A11, A12, A13, A21, A22, A23, A31, A32, A33. Upper triangular matrix, row greater than column 0, row greater than column 0, row greater than column 0, upper triangular. Lower triangular matrix, which one will be 0? Row less than column will be 0. So all row, someone is asking marks. Okay, 9 marks for matrices. 9 marks total. So lower triangular matrix, row less than column 0, row less than column 0, row less than column 0. So diagonal matrix is this. Upper triangular matrix, lower triangular matrix, both. Or you can say in diagonal matrix, only diagonal elements will be there, remaining all 0, 0, 0, 0, 0. Next, in diagonal matrix, if all elements in the principal diagonal are equal, like all are 5, 5, 5, principal diagonal elements, remaining are zeros. This kind of matrix is called scalar matrix. Next, in diagonal matrix, if every element in the principal diagonal is unity 1, then that is unit matrix. The principal diagonal should be 1, 1, 1, remaining all zeros. This is unit matrix. Next, two matrices A and B are equal if the order is same, corresponding elements are same, then you can say A is equal to B. Next, A and B matrices are of same type. Then you can find their sum. You can find A plus B. How? Add the corresponding elements. Matching elements you have to add, you will get the sum. Matrix addition is commutative. That means A plus B and B plus A same. Matrix addition is associative. That means A plus B plus C, same as A plus B plus. Now, A plus 0 matrix is equal to 0 plus A matrix equal to A. 0 is called additive identity matrix. If A plus B and B plus A equal to 0 matrix, then what do you call? B is additive inverse of A. A is additive inverse of B. A is additive inverse of B. B is additive inverse of B. In either case, you can say. A minus B can be written as A plus of minus B. Next, product. If K is a complex number and A is a matrix, you can multiply K and A. How? Multiply every element by K. For example, I'll give you A 1, 2, 3, 4, 5, 6, 7, 8, 9. I will ask you to multiply 2 to A. That means every element has to be multiplied by 2. 2 ones, 2 twos, 2 threes, 2 fours, 2 fives, 2 six, 2 sevens, 2 eights, 2 nines. Every element. Then there are some more properties. K into A plus B matrix is K into A plus K into K plus L into A matrix is KA plus LA. Then KL into A is K into LA. 0 into A is 0 matrix. K into 0 is 0 matrix. 1 second. Sorry, 1 minute. It was not working. Yeah, now it's okay. Now, if two matrices A and B are there, you can multiply them only if number of columns in A equal to number of rows in B. That means number of columns in A, N, number of rows in B, N. It should be like that. Then only you can multiply the two matrices. And how will you multiply? You will get, after multiplying C matrix, in which the elements will be Cij. How will you get this element Cij? by multiplying Aij, Bjk and adding. See, in Aij, Bjk, column, row, see. Here also column, row, same. Like that, you have to multiply the elements, and sigma means addition. For example, I will tell you. Suppose you have A11, A12, A13, A21, A22, A23, A31, A32, A33. This is matrix A. And then you have matrix B. This is 3 by 3 matrix. So suppose if you have B11, B12, B21, B22, B31, B32. This is 3 by 2 matrix. You can multiply because columns here equal to rows here. You can multiply. This is A matrix, this is B matrix. When you multiply, if you are taking first row, you have to take first column. First row, first column and multiply. So if you multiply first row, first column, you will get C11. So how will you get this C11? Multiply A11, B11, A12, B21, A13, B31 and sigma, add them all. In all these multiplication problems, you see here column 1, row 1, column 2, row 2, column 3, row 3, like this. That is what I said. Okay. Next, we will multiply first row, second column. When you multiply first row, second column, you will get C12. Now, how will you multiply this? Here, A11, B12 plus A12, B22 plus A13, B32. Like this you will multiply. See here again. When you are multiplying elements, how you multiply? First column, first row. Second column, second row. Third column, third row. Like this. Okay. Next. You will multiply second row, first column. When you multiply second row, first column, second row, first column, you will get C2. That means how will you multiply? A21, B11 plus A22, B21 plus A23, B31. Multiply and add. Next, you will multiply second row, second column and add. That is A21, B12, A22, B22, A23, B32, like this. Lastly, third row, first column. Here we got to. Okay. Third row, first column. Third row, first column, C31. A31, B11, A32, B21, A33, B31. Next, third row, second column. A31, B12, A32, B22, A33, B32, like this. So you are getting third row, second column, C32, like this. In this way, you will multiply and the order will be 3 by 2. 3 rows, 2 columns. The order from here, 3 by 2. This will be the order of the matrix C after multiplication. Learn this carefully. One time only you won't get it. You have to practice again and again. Okay, next. Next synopsis. If AB exists, then BA may exist, may not exist. Sometimes BA will exist, may exist, or may not exist. Sometimes BA you cannot find. Next, matrix multiplication is not commutative. That means sometimes AB will be equal to BA. Sometimes AB will not be equal to BA in multiplication. If AB is 0, then either A should be 0 matrix or B should be 0 matrix, anyone. If AB and AC are equal, then sometimes B will be equal to C or B will not be equal to C also. Anything can happen. Matrix multiplication is associative. That means AB into C is equal to A into BC. Matrix multiplication is distributive. That means A into B plus C is AB plus AC. B plus C into A is BA plus C. Then if AI is equal to IA is equal to A, I is called multiplicative identity. I is a unit matrix. I will be like this 1, 1, 1, 0, 0, 0, 0, 0. It is called multiplicative identity. Next, if A is a square matrix, A power M into A power N or A power N into A power M will be A power N plus M. Next, idempotent matrix means A square will be equal to A. Involuntary matrix means A square will be equal to I. Nilpotent matrix means A power N equal to 0. And N is called index of the nilpotent matrix. Now, if you change the rows into columns, you get transpose of the matrix. You denote it by AT or A dash. Example, suppose if I give you 1, 2, 3, 4, 5, 6, 7, 8, 9, then A transpose means make this row as column 1, 2, 3. Make the second row as column 4, 5, 6. Make the third row as column 7, 8, 9. This is called transpose of the matrix. A transpose. Next. There are many formulas. This is a very big chapter. That's why 9 marks. And we will also do it for 3 days. Next. If you take transpose double times, A transpose, you will get A. A plus B whole transpose is A transpose plus B transpose. K into A transpose, whole transpose is K into A transpose. AB whole transpose is B transpose into A transpose. Symmetric matrix means A transpose will be equal to A. Skew symmetric matrix means A transpose will be equal to minus A. Every square matrix can be written as sum of a symmetric matrix and skew symmetric matrix. Then transpose of A plus B this is not transpose, this is trace. Transpose is already given you. Okay, the next is trace. What do you mean by trace? I told you already. What is trace? Trace of A, what it is? Suppose A is a diagonal matrix. A11, 0, 0. 0, A22, 0. 0, 0, A33. Trace means add up all the diagonal elements. That is the trace. So trace of A plus B is same as trace of A plus trace of B. Trace of A minus B is trace of A minus trace of B. Trace of AB is trace of BA, same. Trace of K into A is K into trace of A. Now next, conjugate of a matrix. If the matrix is replaced by corresponding conjugate numbers, then that is conjugate of A. What do you mean by conjugate? Suppose A is having square root of 3, 1 minus 2 square root of 2, I, 3 minus I, 1 plus square root of 5, then 4 plus I, then 6, then 0, then 5I, like this. This is A matrix. Then conjugate of A means what? Conjugate of root 3 is minus root 3. Conjugate of 1 minus 2 root 2 is 1 plus 2 root 2. Conjugate of I is minus I. Conjugate of 3 minus I is 3 plus I. Conjugate of 1 plus root 5 is 1 minus root 5. Conjugate of 4 plus I is 4 minus I. Conjugate of 6 is 6. Conjugate of 0 is 0. Conjugate of 5I is minus 5. This is called conjugate matrix. Transposed conjugate matrix means what? Transposed conjugate matrix. You have to take the conjugate matrix and take the transpose. That means first row you will write it as first column. Minus root 3, 1 plus 2 root 2, and minus sign. Second row, 3 plus I, 1 minus root 5, 4 minus I. Third row, 6, 0, minus 5. This is transposed conjugate matrix and it is denoted by A theta. Then if A theta is equal to A, that is called Hermitian matrix. If A theta is equal to minus A, that is called skew Hermitian matrix. Okay. Next, 1 minute, my pen is not writing. Okay, fine. Next one. Inverse matrix. Before learning inverse matrix, you must know what are the cofactors. Every element will have cofactor. What is cofactor? Suppose I will give you A, 1 minus 5, 2, 3, 0, 1, 6, 2, 3. If I give you like this. Now, 1 has a cofactor. What is cofactor of A? Anyone? Does anyone have the idea? What is cofactor? What happened? No one is telling the answer? Does anyone know what is the cofactor? Okay, I will tell. This is in first row, first column. So you have to take minus 1 power 1 plus 1. And then leave this 1 row and 1 column. Whatever is left, write it as a matrix. 0, 1, 2, 3. That is cofactor. That means minus 1 square. You have to cross multiply. 0 into 3, minus 2 into 1. So minus 2 is the cofactor. Cofactor for 1. This number 1. It is written as A11. Suppose if you take another element. For instance, you will take this element, A12. So if you write cofactor of minus 5, how will you write? Minus 1 power, you add 1 into. Then for minus 5 row, leave the minus 5 row and minus 5 column. What are left? 3, 1, 6, 3. Write it as a matrix. Then minus 1 cube, 3 into 3, 9, minus 6 into 1, 6. So minus 3. This is cofactor of A12. Next. For 2, we will find cofactor. Cofactor of 2. The position is A13, first row, third column. So minus 1 power, add 1 and 3. And when you remove this first row, the 2 row and the 2 column, if you remove, left of numbers 3062, write as a matrix. Minus 1 power 4 into 3 into 2, 6 minus 6 into 0, 6. So it is 6. This is cofactor A1. Like that, for every element you can write cofactor. I'll show you. Some more I'll show you, don't worry. Now this is second row, first column, 3. So I'll write cofactor of 3. Power of minus 1 will be 2 plus 1. And when you remove the second row and first column. What are left? Minus 5 to 2, 3. Minus 5 to 2, 3. So minus 1 cube. Minus 5 into 3, minus 15, minus 2 into 2, 4. So 19 is cofactor of A1. Like that, you can find the cofactors. Okay. So now, you will get adjoint matrix, cofactor matrix, 2 types of matrix. How? I'll tell you. Suppose this is matrix A. If you want cofactor matrix, how to write cofactor matrix? Cofactor of A11, cofactor of A12, cofactor of A13, cofactor of A21, cofactor of A22, cofactor of A23, cofactor of A31, A32, A32. This is cofactor matrix. Now, take the transpose of the cofactor matrix. Take transpose of cofactor matrix. What do you mean by transpose? First row, write as first column. Second row, write as second column. Third row, third column. That matrix is called adjoint matrix. Adjoint of A, adjoint matrix. Okay. Now, you can find inverse of A. A is called invertible matrix if A into B will be equal to B into A will be equal to unit matrix. B is called inverse of A is called inverse of B. Every matrix need not be invertible. Some matrix has inverse, some matrix do not have inverse. Whichever matrix is invertible, it has only one and only one inverse. If you can find the inverse of the matrix, only one inverse you can find, you cannot find many inverse. And inverse is denoted by A inverse, like this. If A into A inverse is equal to A inverse into A is equal to I, that means inverse exists. Remember, always A into A inverse is A inverse into A and both are equal to unit matrix. Always I inverse will be I only. If you take inverse double times, you will get A again. The next is AB matrix whole inverse is same as B inverse into A inverse. Remember all these. Then KA whole inverse You can write K into A inverse. A transpose of inverse equal to A inverse of transpose. All these they will ask in multiple choice questions. So learn. How will you find A inverse? To find A inverse, you have to take adjoint A by determinant A. How to find determinant A, I will tell you. What happened? Any doubt? Okay. How to find determinant A? I'll tell you. A into adjoint A will be equal to determinant A into I. These two formulas also you must remember. Only a few more formulas. After that, we will go to problems. Again, after some time, tomorrow we will come back to formulas. Many formulas are there, that's fine. Next. Determinant of A inverse is 1 by determinant of A. Yes, hi. Any question? What's your name? Okay. For a small matrix, 2 by 2 matrix, it is easy to find the inverse. But to find the inverse, AD should not be equal to BC. Remember, AD should not be equal to BC. So how will you find A inverse? Remember this formula for A inverse. A is having AB, CD. You are finding A inverse. So first what you will do? 1 by multiply AD minus BC. This is what you do. Into, now you will write this D and A by exchanging. D and A will exchange. How they will exchange? D will come up, A will go down. Next, you will exchange B and C also. B and C also will exchange this B and C. But while exchanging, they become change in sign also. The sign also will change. B and C will exchange, but the sign also will change. That is what you have done. A and D will change just like that. B and C will exchange by changing the signs. This is how you can find the inverse. Now, if you have okay, I'll make my voice clear. If you have 3 matrices ABC, AB is equal to AC means B equal to C. BA equal to CA means B equal to C. This will happen still it is not clear, Kumar? Can you hear me? Kumar, can you hear me? Okay, fine. The next is adjoint of AB is equal to adjoint of B into adjoint of A. Determinant I will tell you tomorrow.
Determinant of adjoint A is determinant of A power n minus 1. Now let's see for a small matrix how to find adjoint. If there is a small matrix A, B, C, D, how will you find adjoint of this small matrix? Fifteenth. Okay, I'll tell 15th. How to find adjoint of A? Exchange A and D, D and A. Exchange B and C, but change the signs. This is adjoint. Kumar is asking about point number 15. In point number 15, I said, if you have a matrix A, B, C, D, you can find the inverse of this matrix. How? First of all, multiply AD. AD minus multiply BC. After that, you will write a matrix. You will keep A and D exchange. D will come up, A will go down. And then you will make C and B also exchange. But when they exchange, what will happen? The sign will change. Minus C, minus B, like this. This is how you will find inverse. Not you. Another person has asked, I don't know his name. He has asked how, Kumar, not you. Someone else has asked. Okay. If A is a diagonal matrix like this and ABC is not 0, then you can write A inverse as diagonal matrix only, but 1 by A, 1 by B, 1 by C. All remaining are 0, 0, zeros. This is how you can write inverse. So I think for today, these formulas enough. We will do some problems. I will give you some questions. Let us see how many of you will answer correct and first. The answer should be correct and first also. You must answer fast, fast. Here is the first question. Four of you gave the answer as A. Wow, everyone is getting option A. Good. Option A is correct. A square equal to A. What is given? A square is equal to A. They're asking 1 minus A, I minus A whole cube plus A. Actually, they're asking I. It is I, not 1. So, you have the formula, whole cube. I cube minus 3I square A plus 3IA square minus A cube plus A. I cube means it will be I only. I square will be I, so minus 3A. Plus 3, A square is A. Minus, in this A cube also, A square into A. So this A square, we will write it as A into A plus A. These two will cancel. I minus A square you can write as A plus A. So only I is left. This is how you get first option correct. Okay, next question. Here, second question. Kumar got A again? No, not for this. For the first question, okay. I don't know what is your name. You write your name, then I will address you. You are calling me, but I don't know your name. Okay, Kumar is saying D is the answer. And that's right. Yashwant. Okay, Yashwant. Yes, what is your doubt? You raised your hand in the middle, Yashwant, and you're calling me. What's your name? You told me name. Oh, yeah, what's your doubt? Okay, second question. Aij is a square matrix. Aij is 1 when I is not equal to j. And Aij is 0 if I equal to j. So what you will get? And what is A square? A is A11. It is order 2. A11, A12, A21, A22. Like this. 2 by 2. Now what they said? When I is equal to j, this one, it is 0, 0, 0. Yashwant, you want first question? Okay. I'll tell you first question. Wait, 1 minute. Let me complete this. And whenever I is not equal to G0, the element is 1. Here, I is not equal to J. I is not equal to J. So it is 1, 1. Now you have to find A square. 0, 1, 1, 0. You have to multiply with 0, 1, 1, 0. So how will you multiply? First row, first column. 0 into 0 plus 1 into 1. First row, second column. 0 into 1 plus 1 into 0. Next, second row, first column. 1 into 0, 0 into 1. Second row, second column. 1 into 1, 0 into 0. So 1, 0, 0, 1. That is option D. So Yashwant want this first question again. Here, you have to find I minus A whole cube plus A. So you will use one formula, A minus B whole cube. A cube minus 3A square B plus 3ab square minus b cube. This formula when you use, you will have a cube minus 3a square b plus 3ab square minus b cube. Now, in this, I cube will be I only. I square will be I. So what you will write? Just I, 3 into I into A, 3A plus A square is given as A. Instead of A square, I can write A, then 3 into I, 3, minus A cube, I will write A square into A. So this minus 3A and plus 3A will cancel. Now 1 minus, again A square I can write as A into A. I minus A into A is A square. And again A square is A. Okay. Then in the last I have plus A. This plus A. Plus A. Plus A. So minus A and plus A will cancel. I is the answer. Okay, we will end the class tomorrow. We will do more questions.